Welcome, Matt Taylor here with another methods video. This is for exercise 1.3 and I'm going to be talking about how to actually read the questions and what they actually mean, because I know if you don't read the questions right you might end up doing the wrong thing and costing yourself a lot of time because you got to do it again and everything. It's not worth learning it wrong and then doing everything wrong and then having to do it again. So I'm going to talk about I'm not going to actually talk about what the transformations are and stuff because we did learn that in class, but I'm just going to talk about what the questions want you to do, so help you answer them better. So the first question says, state the transformations necessary to achieve the resulting functions. So the initial graph is y equals x squared, so just a basic quadratic, and they're transforming it into 2x squared plus 3. So basically what the question wants you to do is it wants you to write down how the transformations are made and what actually happened to the graph. So I've got it graphed here. This is the original x squared and this is 2x squared plus 3. Like, if you look at it, it's really simple to see what happened. So basically it's been moved away from the x-axis, so if we use the terminology that they use in this here, basically the plus 3 part is this k at the end. So it's been moved 3 units from the x-axis or parallel to the y-axis, whichever way you want to write it, and then you can see it's gotten narrower because of the 2x squared. If all the x values are doubled, it's going to get steeper quicker. So basically what it means, that is the a part, so it's the dilation factor of a units parallel to the y-axis or from the x-axis. So it's getting steeper away from the x-axis or towards the y-axis. So basically all you need to write is that it's being dilated by a factor of 2 from the x-axis or parallel to the y-axis, and then it's been moved 3 units away from the x-axis. That's what the plus 3 means. All these are the same, but you basically have to look out for the cubics, because what happens then is they're not like a quadratic, and basically they don't move the same way. But if it's in brackets like this, it does say here, for odd powers, the function is cubic impedance and has a stationary point of inflection at hk. So basically you take this value negative, because it's negative in this equation, you have to take negative of it. So because this is plus 4, it's negative 4. So the turning point would be at negative 4 on the x and positive 2 on the y. So yeah, you basically look at this equation and it fits into the same form as that. So you basically say, oh well, there's no a in this one, but there is a h and there is a k, and you say, what does h and k do to the graph? Okay, so question 2. Sketch the following graphs considering all transformations. Do not calculate the x-intercepts and y-intercepts. I didn't read the whole question at first. I didn't read the do not calculate the x-intercepts and y-intercepts, so basically I wasted heaps of time just calculating them, because that does take a lot longer than simply working it out the easy way. This question, all it's asking for is the turning point, or the point of inflection, in the case of cubics. Is very, very simple. So this equation has the h is 2, and because it's a positive in here, you're going to have the x coordinate of the stationary point at negative 2, and there is no k, so it's going to be at 0. So negative 2 and 0 is going to be the coordinates for your stationary point, which is really, really simple. Number 3 is a bit harder. You basically just have to find the x-intercepts and the y-intercepts. It says no technology, so you can't really just graph it and do that, but I guess if that's how you want to do it, then that's okay. But if you wanted to find the y and the x-intercepts otherwise, basically if you want to find the x-intercept, you want to make y equals 0, and if you want to find the y-intercept, you want to make x equals 0 and then solve for the other one. So that's how you do that. And yeah, hopefully that helps you out with the first couple questions, and see you in another video. Thanks for watching.